Hello everyone. In this video, we are going to learn about volume and surface area of prism and cylinder. If you use Xingli New Syllabus Mathematics Book 7th edition, you will find this in chapter 14. So by the end of the lesson, you should be able to convert between centimeter cube and meter cube. And then you should be able to find the volume and surface area of cubes, cuboids, prism, and cylinder. And then the final one is you will be able to solve problem involving the volume and surface area of composite solids. So before we start the lesson, the first thing that you have to remember is your metric staircase, which the difference between this metric staircase that we are going to use, it will use cube instead of the normal metric staircase. If you have learned our previous chapter, which is about area and perimeter of plane figures, you know that the metric staircase has a square on it, which means one stair equals to 100. While in the cube or for the volume, what you are going to use is a cube, which is one stair equal to 1000. So in this cube metric staircase, one stair down means times 1000 and one stair up means divided by 1000. Okay, with that aside or with that in your mind, let's start our lesson about volume and surface area of cubes, prism, and cylinder. So, what is volume? You have to understand that volume means the amount of space that a substance can occupy. To get you understand about that a little bit more, I had these two boxes with me here. Let's assume that this two box is filled with something different. The first box, I fill it with feather or cotton, for example. While the other box, I fill it with iron, rock, stone, any, okay? And I fill these two boxes full. Which box do you think is heavier? Well, obviously you know that the box filled with stone or filled with iron will be a lot heavier rather than the box filled with feather, right? So that's when we are talking about mass. However, volume means the things that occupy the space. Let's say that I take out this stone, I open the box and I take out the stone from the box, and then I want to place it with cotton. Even though the cotton is lighter, it doesn't mean that I can put more cotton rather than this much. No, I can't. The amount of cotton that I can insert in this box is just this big of cotton, because we are talking about volume. The space that it occupies, the inside part of the box itself. I cannot, maybe if I had this big rock and this many cotton, I think the rocks will still be heavier, but it doesn't mean that I can put all the cotton in this box into this small container. It won't be possible because the volume are different. Okay, the volume between the box and this big box and the small box are different. That's about volume, and it has a strong relation with what we call density. I believe you have learned density by now. So density is something that determines the mass of a substance. So let's say that's why when we have two exact box and one is filled with feather and one filled with cotton, there will show different mass due to the different density of each substance. But we are not going to learn science today. So that's just so you know that density has a relation with volume, which we are going to talk a bit in this chapter as well. Okay? So you know about volume. So now we will need to understand what is surface area. If volume means something inside or the space that it takes, the space inside, then surface area means the part outside. How to understand surface area easily is, let's say that I want to cover this box with a paper or with a plastic. Then how big the paper that I need? How big the plastic that I need? That is surface area. I will not need to open the box and then fill the plastic or the paper inside the surface, inside the box itself, right? No, I just need to cover it. So surface area never talks about the inside of the box, but it only talks about the outer part. That is surface area. So if volume talking about how many water, maybe how many cotton that I can insert inside the box, then surface area means how big paper do I need to cover the box itself. Okay, so with that in mind, we are going to continue with the formula of each prism and cylinder. Okay, so let's get started. Our first 3D shape today will be cube. To be able to learn about volume and surface area of prism and cylinder, you have to be able to memorize the formula to count the area of plane figures, which is your 2D shape that we learned in the previous chapter. Okay, so when we are talking about volume, the same with our plane figures. If plane figures have area and perimeter, then this 3D shape also had the things that almost the same but maybe a little bit different. The first one is volume and the second one is surface area or SA. So in our plane figures, I told you that you don't have to memorize the formula of perimeter, because perimeter means just like you are run around the field, right? So you run around your figure and then you just have to add all the number. That's why you don't have to memorize the formula of the perimeter, you just need to memorize the formula of the area. While in this case, it is actually almost the same, but still you will get a formula in the end. So when volume, you need to memorize the formula for volume, and it is the same for all figures that we have here. Okay, I will guide you through it. I'm sorry, I will not write it here. The cube, I will just write it on the side. This is cube. So, what do we know about cube? Cube means a square or a figure that has 6 same side, right? It's a box with the face, the back, the left, the right, the top and the bottom made of square, which give us side from left to right, and then from front to back it's also S or side or length, and then from the bottom to the top also side. Why do I put the same? Because let's say that I had a cube with the side of 5, that means from left to right 5, front to back 5, bottom to top 5. That's why I put S, S, and S, or side, side, and side. When we talk about the volume, what you are going to do is you will multiply the length, the breadth, and then the height of the cube itself. That's why you will get side times side times side times side, which will give you side cube or S cube. That's the formula of the volume of the cube. So how about the surface area? Remember that surface area means the amount of paper that you need to cover all the part, the front, the back, the left, right, the top, and the bottom. Okay? So when you want to do that, remember that we had actually 6 equal square in this cube, right? So what I'm going to do is actually I'm just going to find 1 square. 1 square means this is S and the top is S. So since square is side times side, so S times S, S square times 6, which give us 6 S square, or 6 times S square. Let me write it again, 6 times S square. It doesn't matter where do you put the 6. Do you put the 6 at the back or in front like this? It doesn't matter because it is times. So it won't change the value of it. Okay, so now let's get into cuboid. Cuboid. In cuboid we had something different. It's not all side, but in the cuboid we will have length from left to right, and then from up to down we call it height, and then from front to back, since we have length and height, so the other one will be breadth. So the volume of the cuboid is, I will make a line here so that you can see it clearly. The volume of the cuboid will be length times breadth times height. That is about the volume of the cuboid. How about the surface area of the cuboid? Surface area of the cuboid, you don't really have to memorize the formula, but the formula is 2 times length times breadth plus 2 times breadth times height plus again 2 times length times height. Yeah, quite long, but I will show you how can we get this as a formula for the surface area of a cuboid. So when you want to cover this box with paper, we will check one by one. We will check the front part of the box. You know that the front part and the back part is actually the same, right? In the front part, we will have a rectangle. And how do you find the area of the rectangle in the front part? It will be length times height. That's why it is length times height, but you will times it by 2 because it's front and back. Now front and back has covered. Now we will go to the left and the right. The left and the right, which means this box here, you will get the area of the left and the right part by breadth times height. But since we have 2, one on the left and one on the right, we will use 2 times breadth times height. We are not done yet. Remember that we still had the bottom and the top of the cuboid, which will give us, how do you get this part? Remember that this is the length and this is the breadth, right? So length times breadth, but then you have to times it by 2. That's why you get 2 times length times breadth. That is about the surface area of cuboid. So by this you should be able to understand that actually you don't have to memorize the formula for the surface area of a solid figure. What you will need to do is you will try to plus all the outer part, but you need your area formula to be able to plus all the outer part to get the surface area. Okay, so you don't have to memorize it. That's how you do it. And about the volume, even though the volume seems different, actually all volume are the same. I will show you with this third prism that we had here. We call this prism is a triangle prism. So the actual formula of volume is simply base area times height. Base area times height. BA times height. Base area times height. What do I mean by that? Well, when you see a prism, prism means something that has the same base and the same top. You see like our triangle prism here, I will have the same, the prism, the triangle at the bottom and the triangle at the top is actually the same. So that's why I call this prism. And if you notice, cube and cuboid actually also prism. You see in cube, the bottom is square and the top is square. So it is a prism of square. While the cuboid will have the bottom of a rectangle and the top of a rectangle. So cuboid is actually a prism of rectangle. While this prism of triangle, the base is triangle and the top is triangle. So this is the prism of triangle. However, when you change, let's say that you switch this into this form of triangle, for example. Now you see that I just put the prism in a landscape. Okay, so in this case, which one is the base of the prism? Even though now you might think that you see that before it is like this, and now I put it slip like this, you might think that the part that touch the ground will be the base. However, it's not. In a solid figure or in a prism, it's not about which one that touch the ground. You can put this on the sky, you can put the figure everywhere or in any position. The point is, the base area is the same with the top. So it is the two shapes that is the same. In this case, what is equal is actually the triangle here and the triangle on the right side, which means that is the base. Okay, so it doesn't matter if it's in a landscape or in a portrait or even diagonally made. What you have to find out which one is the base by seeing which one is the base and which one is the top. So that will be the base and the top. Okay, it will be the same. The base and the top will be the same. That's what I mean. So let's see, is this really works base area times height with cube and with cuboid? It is. Look, if you see the cube, remember that formula of volume means base area times height. What is the base area of the cube? Cube has a base of square. The base area of the square means side times side, right? That's why we have side times side times base area times height. What is the height of a cube? It will be the side. That's why you have a side as the height. Base area, side times the height, which is as well, side as well. That's why you have side cube, base area times height. That works with a cuboid as well. In a cuboid, you know that the base area is a rectangle, which means length times breadth. Length times breadth. Base area times the height. That's why you have LBH, because it's actually base area times height. In this case, you have to, why we don't have any specific formula for the volume, because the base actually do not stop in a triangle. You have learned about polygons, right? As long as it is a polygon, it can be quadrilateral, pentagon, hexagon, heptagon, octagon, as many gon as needed. So as long as it is a polygon at the base and a polygon at the top, you will use the same base area times height to get the volume. That's about the volume. So how about the surface area of the prism? The same with before. There is no specific formula for that. However, this is the best thing that I can tell you on how to do it. We will count, the first thing that we will count is the base area and the top. So you will plus that, base area times 2 times base area. Okay, doesn't matter what is the base area, so 2 times the base area, plus Now, can you imagine if I open the part that holds the base, that connect the base and the base and the top? If I open it, then it will be a rectangle. It will be a rectangle. Can you imagine? So when you open it, it will be a rectangle. So the rectangle will be like this. The breadth of the rectangle will be the same with the height. However, the length of the rectangle will be the same with the perimeter of the base or of the top. So it is the perimeter. The perimeter will be the length, while the height will be the breadth of the rectangle when you open the things that connect the top and the bottom. Okay? So when we are talking about surface area, you want to plus the top and the bottom, and then you want to plus this part in the middle, right? The one that's standing. And the one that's standing is actually a rectangle. And then the rectangle will be, how do we get the rectangle? We know that the area of this rectangle is length times breadth. But the breadth just now is actually the height. And then the length is actually the perimeter of the base area, right? So not base area, but base perimeter times the height. That's how you get the surface area of any prism. Will it work with cuboid and cube? Yes, actually it will. You will just plus the top and the bottom, and then the perimeter of plus the perimeter of the top or of the base times the height. You will get the same, but for cuboid and cube, it will be easier to use these two instead of this way. Okay, so 2 times base area. Remember, 2 times base area because the base area and the top area plus the area for the standing part or for the part that connects the top and the bottom, which is base perimeter times height. That's how you do the prism. How about cylinder? Cylinder is, if you see cylinder is actually almost the same with prism circle. That's why they had 2 circles, right? At the top and at the bottom. However, we cannot call this cylinder a prism because prism needs a polygon as a base. While in cylinder, the base is not a polygon but circle. We cannot count circle as a polygon because circle has no sides, or the sides is infinite, right? But since it has almost the same characteristic as prism, we can conclude that actually it has the same formula for the volume and for the surface area, which is the same for cylinder. The volume will still be base area times height. The base area, however, you will use circle as the base area, while the surface area, or when you want to cover everything, you need to cover the base and the top, which is 2 times base area. Why 2 times base area? Because the top will be the same with the base, right? So it will be 2 times base area plus, now imagine again this middle part. If you open it, it will be the same with a rectangle. What is the breadth of the rectangle? The height of the cylinder. And what is the length of the rectangle? So the length will be the same with the perimeter of the base, right? So it will be base perimeter times height. So basically, when you are talking about volume and surface area, or when you are talking about 3D figures, basically most of them had only one formula for the volume, which is base area times height, and one formula for surface area, which is 2 times base area plus base perimeter times height. and it works for everything. However, for cube and cuboid, if you want to make it easier, it will be better to memorize this formula or to understand the formula. Okay, to end up today's lesson, I will show you that this is actually let's pretend that this is the cylinder that I had here, right? So as I told you that, the base and the top is the same, but when we open it, it will be a rectangle, right? This rectangle the height of the cylinder will be the breadth of the rectangle, while the length of the rectangle will be the perimeter of the base. Okay, so that's why we get all this formula. I think that's all for prism and cylinder. I hope you learn well. I hope you understand the lesson. If you are not, then please ask me anyway. And I hope you will be able to understand this. Thank you very much. See you in the next